Hi and welcome to this seminar about the encryption technology, the new encryption technology from Microsoft within the Microsoft Information Protection Suite. My name is Anders Olsson. I work as an IT and Information Security Advisor here at Onevinn, and have been working with this kind of technology for about 10 years. When it comes to the new double key encryption, we started the dialogue with Microsoft for about 2 years, provided feedback from Swedish customers and so on with requirements that we have. So the content for today and the agenda for this webinar is actually a deep dive. I hope that this was totally clear in the invite, that we're going to focus on all the encryptions part in this session. And again, this is a really new thing when it comes to encrypting information. And within the Microsoft Information Product Suite, basically, I would like to spend just a few minutes to just mention what we are not going to talk about today, because the Microsoft Information Protection Suite is really big. It's a lot of solutions out there that's actually helping us to meet the different business needs that we have to be able to protect our information. So basically today, I am not going to talk about how we are able to classify information, both in the on-prem as well in the cloud. I'm not going to talk about how we are able to automatically detect sensitive information, both in the on-prem environment as well in the cloud environment, not only Microsoft Cloud, as well as other third-party cloud solutions that we are able to identify sensitive information. I'm not going to talk about that today. I'm not going to talk about how we are able to use different data loss prevention scenarios to meet the business requirements, to block certain things and so on. That is not the agenda for today. I am not going to talk about how we are able to monitor, get insights about our information, both internally and externally with these kind of solutions today. So basically, I'm not going to talk about everything around these type of things. I guess that most of you doesn't listen right now. You just try to read what you have on the screen. So basically, this was just to summarize that Microsoft Information Protection is a big suite of products, a lot of solutions out there that is meant to help to meet the business need when it comes to information protection. So, okay, the agenda for today again is to talk about how does the encryption actually work with these kind of solutions when we classify sensitive information. I want to protect it as well. First of all, if we're looking at the key options that we have out there today when you're starting out using this, the agenda for today is a new technology that is still under preview. It will be released in about 2.5-3 weeks during Ignite. So it's really new things coming out here. But what do we have today? What kind of options do we have? First of all, when we establish a new tenant and activate these kind of services to be able to encrypt the information, we get what we call a default cloud key. This key is it's unique for your tenants. So basically, it's your own, and you're using it to encryption all kind of files and so on. If there is a business need out there to generate your own keys, we also have an option to use a scenario called the bring your own key. This is basically, if you need to create your own key, you can do this. You need to have an HSM, a hardware security module. This needs to be something from Thales in this case. And what you're actually doing here is that you generate your keys in this hardware security module. The concept of an HSM is to protect your keys and block all kind of extraction of your keys. But if you're using the option bring your own key, I want to use this with Azure Rights Management in the cloud, you still need to transfer your keys into Microsoft HSM in the cloud, in the different data centers. The whole concept of HSM is the possibility, and why you need to have this from Thales or Gemalto in this case, they bought Thales, is that you transfer your keys into Microsoft HSM. They're using the same thing in their data centers, which make it possible for Microsoft to actually use your keys when you need to protect information, both locally in the on-prem environment as well when you're storing information in the cloud. So the benefit of this, and when you want to use this, except that you create your own keys, is also that you get more insight in the use of the keys. As soon as some decryption and so on are happening, there's a log about it, regardless of key option. But if you're using the bring your own key, you can also verify a log when your keys was used. So you can match, depending on your actions out in the cloud or when you try to decrypt anything, you can match if your key was used and if it's being used outside of this. So that is more if you want total insight of the keys. In that case, using that. The third options, and what we're going to focus on today, is this one. The hold your own key, which is basically that you own the key. You can have the keys wherever you want in your custody and use that together with Microsoft Information Protection to be able to protect sensitive information. What is used today is the classic Active Directory Rights Management Services, RMS. I think it's been there for almost 20 years now in the local AD as a role on your Active Directory. And to not frighten you and so on, it's not deprecated. I have not seen any date if they're going to stop supporting it and so on. So the concept of AD RMS is still supported to use, but there is a lot of limitation with it. Basically, it's using your Active Directory for authentication when you protect anything. And the limitation with that is that you only have the possibility to encrypt information to AD accounts that you have in your on-prem environment. So basically, it enforces you to have your machines that you're using, mostly Windows devices, in the on-prem environment where you can access your AD RMS solution. And it gives you the options to encrypt things to your on-prem users in the local AD. So there is almost no support at all to be able to protect things to external parties, as they call business to business and so on. I say almost because it could be achieved if the other part also using AD RMS and you're sharing trust and so on. It's possible to achieve that, but almost no one does it. And it's really hard to work with it. And another limitation is these kind of devices. I get an iPhone here. It could also be an Android device. It could be a Mac machine. It could be a Linux device or whatever. It's not going to work with your AD RMS. So basically, what we need here is something that adjusts how we work today. What are our end users using today? And if they are using iPads or iPhones or Mac machines or whatever, if you're using manual classification and enforce or tell your users to classify and protect things, if they can't use their devices, they're not going to protect anything. The other thing with hold your own key and the AD RMS is a connection with your unified label that you're using with the Microsoft Information Protection. For those of you who are working with this, you know that you can assign a sensitive label that you can assign to your classification, and you can connect this with the AD RMS templates, which make it possible for the end user to classify a file, and that file will be protected by your AD RMS. Today, this is handled by the classic and old Azure Information Protection Portal. It's also using the classic AIP client, the version 1 client. If we read on docs, in this case, we can read that the AIP Classic client, as well as the AIP portal, have an end of life or going to be deprecated during next year. So if you have the business need to still be able to classify and label your information as well protecting it, you can no longer using ADRMS. You need to have something else. So, and also when it comes to keys option and the different classification and sensitivity of information, there is not meant to be, if you have the need to use the hold your own key scenario, it's not meant to be for all kind of information. In the same way that you are not protecting all your information, you protect the information that is sensitive. So if we just looking at an example of information classes, in this case, we maybe have confidential and secret information that we need to be able to encrypt and decrypt. We need to share this with external parties. We maybe have the need to open up these kind of information in the Teams clients using the online apps, Word Online, etc. And maybe co-working with the document and so on. In that case, we are using the Azure Rights Management. In that case, you have the default key option to use, and you can also use bring your own key option. Because in that case, Microsoft have the access to the keys and they can provide you with all the services that you need to be able to use this. When it comes to really sensitive information, one business case could be information that you haven't got digital today. You have it on normal papers locked in somewhere today. In those cases, it's meant that you're using the hold your own key scenario. And in the past, using ADRMS, which gives the possibility for me as an end user to choose the correct classification, encrypting files, and it will automatically encrypt the file with ADRMS. With the limitation that you need to be on-prem in the most cases to get this to work. So how do we actually solve this, and what is the new thing of hold your own key? As you maybe saw in the invite itself, it's called the double key encryption, DKA. What is the concept of that? It's actually, if you see the screen right now, I'm guessing here, but I think that most of the audience here is Swedish. In English, it's called, what you're having here is a safe deposit box. In Swedish, it's a postfack eller bankfack. That is actually something that was provided by the bank itself. If I have some papers, photographs, or whatever that I need to store somewhere, I have the possibility to order this by my bank service. The concept was quite easy. It was depending on two keys. The bank had one key and I had another key. If I needed access to my safe deposit box, I need to schedule a time with the bank. I need to go to the bank. I need to show some ID. Who are you? What is the time right now? The bank took the log when this was used and so on. And then in the room, the bank had their key. I provided my key. With both of the keys, we were able to open the safe deposit box. And the bank was responsible for the log and everything around that to have the full audit of who opened what and when. This is basically the same thing as a double key encryption scenario. So what we're having here is you actually own your own key. This is something that you're responsible for yourself, and you can limit the access totally from any third party because you own it. It's based on a web service. It's open source, which means that you can actually put this totally wherever you want. I set this up for a couple of months ago on an on-prem Windows device in my on-prem environment because I'm a Microsoft person. I'm using Windows. But I could have used some Unix system. I could have put this key on a third-party cloud provider if that was something that I needed. But still, I am able to define who should have possibility to access my key. For instance, if there is a need to block a certain country or whatever, I can put a firewall or whatever to blocking certain IPs or whatever to access my key. And when it comes to the end users, basically this is something that is going to be built into Office. It's already built in to Office for Windows in the modern Office, also called Office Pro Plus. One of the greatest benefits with this is that Office, the modern version of Office, is available on all kind of devices. Remember this one. I can install Word app, Excel app, Outlook app on my iPhone, for instance, on my Mac device, on my Linux device. I didn't use that, but yeah, again, if I had a Linux device, as long as I have a modern Office version, Office Pro Plus also called, in that case, it will support this. And the end user's experience is not something additional login or another certificate or key or whatever to accessing something that is protected with the double key encryption technology. Because it's using, when you sign in into Office, I sign into Office and so on, and my token, the web token, is used to authenticate to your web service, to your own key provider, which make no more additional logon for the end users. And this is meant to just work, not experience some additional for the end user in this case. And also for those of you who are working with Azure Rights Management or ADRMS, you know that the first time you open up or decrypting something, you need to be online to authenticate to the service. We're going to talk about this in a couple of minutes more. But if there was a business need to be able to access protected content even offline, we have the possibility to centrally define per sensitivity label if we allow offline access or not. So we can decide that you can access content in 7 days, 30 days, or forever on a certain device, which means that you authenticate to the service, you get everything you need for that device, and we can centrally decide if you should have access to open up this document even offline for 7 days or 30 days, whatever. We have the same possibility with DKA. It's building on the same thing. So for those of you who are working deep dive with this, you still use a URL file on the device, stored on the device, to be able to provide offline access. If that is defined, you can, of course, turn it off as well. Totally based on the business need again. So the purpose here is that we're going to try to explain how does this actually works in the background. To be able to do that, I would like to have some scenario, something that we can relate on and so on to make this more, what do you call it, pedagogist. We need a scenario, something to relate on. And I have two favorite of persons here. They are called Sheldon Cooper. This is a scientist, and they also have a neighbor called Penny. Okay. So in this case, the scenario is that this professor, Sheldon Cooper, that is a scientist again, and he needs to educate his neighbor Penny in science. He himself called this a project gorilla, that he's the project to teach actually his neighbor in science, and he need to be able to share his science in a protected way with his neighbor. So in this case, we also get the requirement, maybe from Sheldon himself or from his business, that everything that is protected for Project Gorilla needs to be protected with a key hosted by his organization. So let's see how we helps out with this. What should we do in the background to get this working? First of all, for the DKA, we set up the web service that is already done. See that the yeah, whatever. We create a label first of all. We define what kind of sensitivity is it. We need to have that from Sheldon himself. Is this secret information, confidential, or whatever? And in this case, Sheldon told us that this is confidential information. Okay. We then create a label for Project Gorilla that is only going to be visible for the members of Project Gorilla. Let's look at the settings for Project Gorilla. Here we can decide what kind of encryption are we going to use. So first of all, we need to define who should have access to this. You also see that we have the option to allow offline access or not. In this case, no. We need to have every access authenticated in all times. We also have the permissions for this. And for those of you who know the RMS concept, the one who apply the protection have always full control of it. And in this case, Sheldon want to make sure that whatever doesn't matter who applied the protection, Sheldon will have full access to the information. So we actually put Sheldon himself as a co-owner of everything that is protected by this label. We also want to make this easy for Sheldon and his business and his project. So we define a group that is also using the self-service in the background with Sheldon as the owner for the group, for the members of Project Gorilla, which means that Sheldon himself can add and remove members without calling the IT to his project, which giving access or losing access to information, basically if you're a member of the group or not. We also have, we don't have time for quiet minutes during these 40 minutes, but we also have an external party in this case. We have his friend Stephen Hawking that's needing access to this information as well as an external party. So we're adding an external party to this label as well with his email address. Okay, then we have the business need of using an encryption with our own key. So in that case, you see that we have the double key encryption scenario out there. We define the URL for my DKA key that I own, and I decide who should access and so on to use for this label. So this is what is configured in the back end. Let's look at Sheldon's machine. Here we have the science. He apparently have some document, I don't understand a word of it, but it's included in the Project Gorilla. And we could have implemented solutions that automatically set the correct label, protection, and so on. We could have recommended Sheldon to do anything. But in this case, he's starting out manually to design what kind of classification is this and how should it be protected. So in this case, Sheldon Cooper defined this is confidential information. And this is from a Project Gorilla. So what we're doing here is that we classify the information, we get the metadata into the document itself, so that it's readable by all kind of third parties, but it comes to what kind of sensitivity is it. And we're protecting the information. Okay. Let's look in the backend. What's actually happened here? Sheldon Cooper had a modern version of Office. He had the sensitivity labels out there. He was able to classify protect files. How could this happen? Okay, so we have, this is Sheldon's machine. We got the Azure Rights Management in the cloud out there. Nothing different from the classic scenario. First of all, there is something that's called a bootstrap that's happened to the client the first time he accessed this kind of service. It could be that he installed and logged in into a modern Office. It could be that he installed the API client or whatever. There will be a bootstrap process, which is meant to be he authenticates himself to the service and he getting back a certificate for his user to his device. This certificate is not an X509 certificate and so on. You can't find it in the search store on the Windows device, but it's still following standards. It have a public key, it have a private key to the certificate. And this is downloaded to his machine. Your organization key, regardless if you're using the bring your own key or you're using the default key, the key that you're using for encryption in the cloud also have a public part and a private key. So what's happened next is that he downloaded the public key from the Azure Rights Management to his device. And with these two, the end user certificates and the public part of the organization key, he's able to protect things with Azure Rights Management. But in this case, it's also using the DKA, the double key encryption scenario. So what's also happening here is that his client will connect to the DKA solution. And the same way, he will authenticate himself with the same token that he signed into Office with. And he will get, in the same way, the public key of your own key to his device. This is actually happening when you roll out a label with the DKA setting configured. In that case, this will happen on the device. And that makes it possible for Sheldon to actually classify and protect things even that he is offline. Because he needs to have access to the public part of the keys, he needs to have a user certificate on his device. Okay, so you can encrypt files. So what's actually happened when he encrypted this dark matter something document? First of all, he chose the correct classification of the file. So we have the classification Project Gorilla, if it's confidential information, and we have the encryption part. This is similar to, basically it's starting out in the same way as classic Azure Rights Management. It's similar to EFS encryption and so on. Everything that is protected by RMS is encrypted by a random advanced encryption standard key, so protecting the files. When it comes to DKA, we are using only 256 bits encryption for this random key. If you're using classic Azure Rights Management, we still have a scenario where Office files are protected with a random key that is 128 bits. Basically, because Microsoft still needs to support really old Office version out there. As soon as they can put this away and stop supporting legacy Office, it will be enforced to be 256 bits. So with Azure Rights Management, when you protect non-Office files, it's also 256 bits. But as long as it's Office files with a classic encryption, it's 128 bits for now. So, but again, DKA is using 256 bits encryption for the random key. And this encrypts the content of his document. What will happen next is that we take this random key and we're actually using the customer's, your own DKA key, the public part of that, to encrypt this random key with the DKA solution. So now we have a unique randomized content key that encrypts the document, and this is also now encrypted by your own DKA solution, your encryption solution. So what's happened next is that we're taking the policy that we had in the label, the permission, who should have access and so on to this file. So we're taking this, we had the Sheldon Cooper, we had the Gorilla group, we had the external user and so on, and the requirement, we will not access anything offline. You will need to authenticate yourself every time you decrypt this kind of content. So we take this in the next step, we take this encrypted content key, encrypted by your DKA servers, together with a policy, and we encrypt this one more time. That's why it's called a double key encryption. So now we have taken the encrypted content key, we encrypt this together with the encrypted policy with the organization key of the Azure Rights Management Service. And we also sign this with the user's certificate to be able to see who actually protected the document. And that is the file that we now have protected. Okay, so what's happened now? Yeah, Sheldon save his document on, okay, we're going old. He have a USB drive. So he take his USB drive, he walks over to his neighbor, knock on the door, often 3 times, and he gives the USB drive to Penny. Here we got Penny's machine. Penny has, as most of the users do, they put in the USB drive, they drag and drop this into the desktop. So you have a totally disgusting desktop with a lot of files. But no matter, she has the Word file on her machine and she open up this Word file. So what will happen here is that it will start in Word. it will open up the document and she will see that this is encrypted. This is classified as confidential, is Project Gorilla, and she have access with some limitation in this case. Because we have defined, based on the requirement from Sheldon, that she would be able to edit this information, but should be blocked from all kind of extraction, which means that Penny can't copy anything and can't print anything. She can't using the print screen on the device. She can't even share this kind of file during the Teams meeting that we're having right now, because it doesn't allow that. But she was able to actually decrypt and open up this information. So let's see how that could happen. First of all, we get Penny's machine. You get it right there. Oh, it's the same machine that I have actually. And she also had the bootstrap scenario happen on her device, you know, the download, the authentication part and so on, the user certificate. Or this happened the first time she using the service. Maybe it's happened right now in a couple of, almost 1 second. But we'll go to Microsoft in this case. The document is totally on-prem. It's on the USB drive. It's never seen in the cloud and so on. So what will actually go to Microsoft? We will send the encrypted policy to Microsoft for the file. No information regardless of the file itself. And also, Penny will send her user certificate to say, who are you, into the cloud service. This is similar to the bank service if you compare with the safe deposit box. So what will happen right now is that the Azure Rights Management Service can use the default cloud key or the bring your own key that you're using in the cloud. That was part of the encryption part. And use the private key to be able to decrypt this policy. And this policy including who should have access to the content itself. And in this case, Penny was authenticated. Penny is not Sheldon. She is not Stephen Hawking. She could be a member of the group. This is verified. Again, similar to the bank service. Azure AD will verify her access. Are she a member of the group or not for the moment? If Penny is a member of the group, the following will happen. We will get the encrypted content key that encrypted the file in the first place. And we will use Penny's settings. In this case, you should have added possibility to this file to create a new policy. This policy is going to be encrypted by Penny's user certificate and her public key. So what's happened right now is that her Office Pro Plus using this technology, and it will receive this protected content key as well as a protected policy for the file to her machine. Still, it's protected only to her and so on. If there is some in the middle or whatever, it should take this file, it can't be used because it's only possible for Penny to use it. And this means that Penny can use her private key of her user certificate to be able to decrypt this encrypted policy, which gives her, again, the actual policy for the file, her permission to the file, as well as the still encrypted content key that have the access to the file itself. So what's happened next if you're using the modern Office that's supporting this and so on, it's that Office Pro Plus will now connect to your environment, wherever you have this. Again, I use my on-prem Windows environment. And in that case, it will connect to my environment and send this encrypted key to your DK solution with the authentication of Penny and so on. Which means that the DK environment that is still as in your custody can use the private part of your DK key to be able to decrypt the key, the content key, and gives this back to Penny. Which make it possible for Penny to use the content key with her permission to the file itself and decrypt the file. And in the next step, it will be decrypted on her device. Again, your Windows device, your Mac device, maybe this kind of device. So that is basically how the DKI encryption works. Almost 3 minutes left to talk before we stop with the questions. But basically, what this is all about is that the encryption technology that is used is what is called the client-side decryption, which means that the decryption part needs to happen on the client side, on my device, to be able to decrypt files. And with that said, compared to what is called the server-side decryption, that is going on with the services in the cloud, for example, Office Online, Teams Online, and so on. In those scenarios, you won't be able to open up anything that is protected by the DK key with the online solutions, because Microsoft doesn't have access to your key at all, which means that you have no possibility to use co-working, co-authoring with a document, for instance. You can, of course, store the files wherever you want. Nothing blocking that. This file could be stored in Teams, in SharePoint, in OneDrive, but as soon as you as an end user open this up, it will tell you you need to open this with your real Office apps. So that's basically what we're having here with the DKA.